Alrighty, so today we're going to start talking about complex numbers, okay? Now, as of yesterday, when I gave you an equation, x squared plus 1 equals 0, we would say x squared equals negative 1, and we would, say x equals plus or minus the square root of negative 1. And yesterday, when we had that, I said we had to stop, and there are no real solutions. Okay? A quadratic, if it doesn't have any real solutions, it still has what we call complex solutions. The complex number system is a system that allows us to keep going on problems that we would have to stop on if we were just using real numbers. Okay? Because that's what they did. You're using it, guys, just stay with me, all right? The complex number system is so that we can continue solving equations that would not normally be able to be solved with real numbers, okay? So that we can find the complex roots of quadratics. So the complex solutions to this quadratic equation are x equals plus or minus I. Okay? I is the imaginary number, and I is equal to the square root of negative 1. Okay? I write my I with a little tail at the bottom so that it doesn't get confused with a 1. Okay? But write it however you need to. I is the imaginary number, and it is defined as the square root of negative 1. Okay? I'm sorry? Because in the real number system, we cannot take the square root of negatives. In the complex number system, we are now allowed to take the square root of negatives. Just stay with us, and let's get through some of it. Okay? All right. So I is defined as the square root of negative 1. And I squared is negative 1. That's because the square root of negative 1 times the square root of negative 1 would give us negative 1. Okay? So look at number 2. The square root of negative 5. I would think of that as the square root of 5 times the square root of negative 1. Can the square root of 5 be simplified? Nope. Can the square root of what is the square root of negative 1? I. So it's the square root of 5 times I. You can either write this as I root 5, or you may write this as root 5I. Both of these are correct. The I allows us to take the square root of a negative number. I is the square root of negative 1. So you can either write it as I root 5, or you can write it as root 5I. So
basically you're just taking away the negative and square rooting of 5 negative 1 and making it I.
Well, would you agree that the square root of negative 5 is the square root of 5 times the square root of negative 1? Yeah. Okay. So we know that the square root of negative 1 is I. That's what I just taught you. Well, no, not really. Negative 5 is 5 times negative 1. Yes. Yes. Okay, guys, it's going to be really important that we just kind of power through a couple examples because it is confusing, but we've got to get through some, okay? We have a lot to get through, so I do want you to ask questions, but try and just trust me a little bit, okay? All right, the square root of negative 12. I'm going to rewrite this as the square root of 12 times the square root of negative 1. Do you agree with that? Okay. The square root of 12 breaks down to 4 times 3 and 2 times 2. So we get 2 radical 3 times, what's the square root of negative 1? I. So I would rewrite this as, these are being multiplied. So you multiply the outside, so 2I root 3. It's just this time when there's another constant with it as well, you'll normally see it in the front like this. Okay? Okay, look at C. How am I going to split it to think about it? Okay, so I have 2 times the square root of 25 times the square root of negative 1. Now, are you going to have to write out this step each time? No, you're going to start getting more comfortable with it. But for now, it's a good step to have. So this is 2 times, what's the square root of 25? And the square root of negative 1. I. So this is 10I. Okay. Negative 3I times the square root of negative 24. So this is negative 3I times the square root of 24 times the square root of negative 1. How does the square root of 24 simplify? 6 and 4. 2 and 3. 2 and 2. So how could I rewrite the square root of 24? 2 root 6. I still have my minus 3I. And what's the square root of negative 1? I. Okay? So I'm going to continue on with this. Negative 3 times 2, negative 6. I times I, I'm going to write down as I squared. And then I still have my root 6 in the radical. Nope, we're not done yet. I squared is equal to negative 1. Okay, this is an important property as well that you got to know. I squared equals negative 1. So this is negative 6 times negative 1 times the square root of 6, which gives us 6 root 6. I times I is I squared. Questions? The complex number system, that's why it's here, so that we can evaluate stuff we wouldn't have been able to evaluate before. Okay? Try not to think of it in terms of real and not real. Try not to worry about it in that sense. Just try and think about it as simplifying expressions. Okay? Yeah. Because I told you that I squared is negative 1. Okay? Okay. In the complex number system, that C with the double back means complex numbers. In the complex number system, the square root of A times the square root of B does not equal the square root of A times B. Okay? You have to simplify first, then multiply. So, on number 3, I've got the square root of negative 5 times the square root of negative 8. So I'm going to simplify both of them. So the square root of negative 5 is the square root of 5 times the square root of 1, negative 1, which is I root 5. Would you agree with that? Okay. The square root of negative 8 is going to be the square root of 8 times the square root of negative 1. How does the square root of 8 simplify? Okay, so this is 2 root 2 times I. Or you could write this as 2I root 2. All right? Multiply everything on the outsides. So I times I is I squared. And I still have this 2 here, right? So 2I squared times the square root of 5 times 2 is 10. Okay, what is I squared? So this is 2 times negative 1 root 10, which is negative 2 root 10. I know it's confusing, okay? Don't blame the messenger. I didn't come up with this. All right. Number 4, 3 root negative 6 times the square root of negative 3. I want you to try that one on your own. Remember, you have to simplify each one first before you multiply. How'd you do? What questions do you have on these steps?
So after you multiply inside brackets, you are allowed to you can simplify it again.
Yes.
Okay.
Yes, 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 yes. Other questions? Other questions? Okay. So, eyes operate in a pattern. Okay? Eyes operate in a pattern. So we're going to figure out that pattern, and then it's going to help us as we simplify larger powers of I. Okay? So, I to the first is just I. I squared, what did I tell you that was? Negative 1. Okay? I cubed, let's think about it. I cubed is the same as I squared times I, yes? Okay, because remember with exponents, we can multiply them, or when we multiply bases that are the same, we can add the exponents. So I squared is negative 1, and I to the first is I. So negative 1 times I, negative I. So I cubed is negative I. No, the square root of 1 is 1. Guys, just kind of try and stay with me a little bit. Okay? I know it's frustrating. There are certain times in math where you just have to kind of throw up your hands and say, okay, I accept it. Fine. You win, math. Okay? All right. Yes. No, I cubed is I squared times I. Which would then, if you did, guys, I can't answer a question without y'all talking. Even if you wrote this as I times I times I squared is negative 1 times I gives us negative I. Okay. Let's look at I to the fourth. I to the fourth is the same as I squared times I squared. I squared times I squared is negative 1 times negative 1, which is just 1. Okay? Let's look at I to the fifth. I to the fourth, or sorry, I to the fifth would be I to the fourth times I, which is, I to the fourth is 1 times I, so we get to I. Hang on. I to the sixth would be I to the fourth times I squared. What's I to the fourth? 1. What's I squared? So what's I to the sixth? -1. What do you think I to the seventh is going to be? -I. And what about I to the eighth? 1. Here is your pattern. You need to memorize these 4. Okay? This is the pattern, and it repeats every 4th term. Okay? So, a really cool rule that comes out of that is I to any power that is a multiple of 4. I to the 4th, I to the 8th, I to the 12th, I to the 16th, 20th, 24th, I to the 400th is always going to equal what? 1. Okay? That's what we're going to use to help us simplify higher powers of I. Yep, Reese? It is? Which is? Okay. All right. Let's simplify I to the 29th. Okay? Okay. Our mode of action, our plan of action when we have ones like this, okay, we're going to look at our exponent. We're going to find the highest multiple of 4 that is smaller than our exponent. So what's the highest multiple of 4? 28. I to the 28th times I to the first gives us I to the 29th, yes? 28 plus 1 gives us 29. Okay, I to the 28th. The reason we do it as a multiple of 4 is because I to any multiple of 4 is always what? 1. So this becomes 1 times I to the first, which is just I. So what is I to the 29th? I. Okay. Yes? No. The reason that it works for multiples of 4 is because that's when our pattern repeats. So you're always at the end, but it won't necessarily work for the other ones. Okay? All right. I to the 100th power. It's a multiple of 4, so what is it? 1. Everyone okay with that? Okay. I to the 17th plus I to the 35th. So we're going to break them down separately, and then we will add them. So let's start with I to the 17th. We're going to rewrite this as I to the 16th times I to the 1st. I to the 16th becomes 1, and I to the 1st is just I. So I to the 17th is I. Okay? Now let's do I to the 35th. So I to the 32nd plus, times I what? To the 3rd. I to the 32nd becomes 1 times I cubed. Look back at your chart. -I. What is 1 times -I? -I. So we have I plus -I, which is 0. Because look how it started. Okay? All right. Sure. Okay, let's look at D. I cubed times I to the 13th plus I to the 52nd. Okay? You can go ahead and simplify the inside and then multiply by I cubed. To me, though, that means I might have to simplify 2 separate times, and that's annoying to me. So I would rather distribute and then just have to simplify once. But it's up to you. Okay? I'm going to go ahead and distribute. So I cubed times I to the 13th, I to the 16th, plus I cubed times I to the 52nd, I to the 55th. All right? Let's work on the left side. I to the 16th is 1. Everyone okay with that? Plus I to the 52nd times I to the 3rd. I to the 52nd is 1. So this is 1 plus 1 times, what is I cubed? Negative I. 1 times negative I. So this is 1 plus negative I, which is 1 minus I. Okay? This number here is called a complex number because it has a real part, the 1, and it has an imaginary part, I. Okay? Yeah. I was just showing that we're going to simplify this right-hand side altogether before we add it to 1. So it was really just me thinking this. Okay? Sometimes all the i's and the plus, it can just get a little confusing. Okay, so a complex number combines a real number and an imaginary number. It is always written in the form a plus bi. Okay, it's got to be written in that form where a is the real part and b is the imaginary part. All right, so when we are combining complex numbers, we've got to make sure, we're only combining the real parts with the real parts and the imaginary parts with the imaginary parts. Okay? So look at 6. 2 minus 3i minus 14 minus 7i. So would you agree that I've got to distribute that negative? Okay. So I'm going to rewrite this as 2 minus 3i minus 14 plus 7i. I just distributed that negative. Okay? All right. Let's combine like terms. So combine your real parts and then combine your imaginary parts. So 2 plus negative 14, negative 12. Negative 3i plus 7i. Okay, so plus 4i. No, it could be minus. Okay, but is this in the right order? Do I have my real part first, then my imaginary? So this is my answer. Nope, nowhere you can go. Huh? Not going to answer that question. All right. Nothing. All right, number 7. 3i times 2 minus 7i. What are we going to have to do with that 3i? Distribute. 3i times 2, 6i. 3i times negative 7i. Let's break it down piece by piece. 3 times negative 7 negative 21. I times I squared. Okay? So let's think about I squared. I squared is what? Okay, so this is really 6I minus 21 times negative 1, right? Because I squared is negative 1. So 6I minus 21 times negative 1 becomes 6I plus 21. Good, I've got to reorder it to be 21 plus 6I. Specific reason for what? That's just just like we have standard form for a quadratic or vertex form, this is the simplest form of a complex number. Okay? Correct. It's just like if we had like 4x, I couldn't split those. I've got to keep them stuck together. Okay? All right. 2 minus 3I times 4 plus 7I. What do you think we're going to have to do? Double distribute. Okay? So, let's start by distributing our 2. 2 times 4. 2 times 7I. So, plus 14I. Okay? Now distribute your negative 3. Minus 3I times 4, minus 12I, and negative 3I times positive 7I, minus 21I squared. So let's think about what we're going to do from here. Write these down so that you can have them at home when you do your homework. All right? We treat it kind of like variables and stuff. We have like terms that we can combine. Okay? So, we can combine 14I and negative 12I. So I would get 8. Then what? Not minus, plus 2I. Okay? And then minus 21I squared. Well, that I squared is negative 1. So minus 21 times negative 1 becomes plus 21. So how do I rewrite this in the correct order? 29 plus 2I.
When we started with double distributing, if one of those parentheses, if it wasn't written in standard form, could you still do it?
Yes. Is there another question? No. Okay, look at 9. We're not going to work the whole thing out, but tell me what I would have to do. Double distribute. 3 minus 4I times 3 minus 4I. Okay. Now, remember, I is defined as the square root of negative 1. Okay? I is defined as the square root of negative 1. So, I is essentially a radical, right? It's a square root. So, just like we couldn't have radicals in the denominator, we can't have I in the denominator, okay? So, we're going to use a very similar process to what we talked about yesterday to get rid of the i's in the denominator. So, let's start with 10. Negative 4 minus I over 5I. What's the problem? I in the denominator, okay? There's I in the denominator. So, what do you think I can multiply the top and the bottom by? I don't have to do 5I, just I. You could do 5I. It won't give you a wrong answer. You'll just have more work simplifying. But just like if that was 5 root 3, I would just have to multiply the top and the bottom by root 3. Okay? So I multiply the top and the bottom by I'm going to distribute I times negative 4 negative 4I. Negative I times I is minus I squared over 5I times I. Okay, I'm going to go ahead and write it as 5I squared, but you are correct. All right, let's simplify that numerator. Minus I squared, what does that become? Plus 1. So how could I rewrite my numerator? 1 minus 4I over 5I squared is negative 5. Put that over negative 5. Now, I'm 98% there. Okay? I'm almost there. My last step is just to rewrite it as a complex number in the right form. So I've got to split it up into my real part and my imaginary part. Okay? So I'm going to put 1 over negative 5, which is negative 1/5. And then I've got negative 4I over negative 5. So that becomes plus, and I'm going to write it as 4/5 I. So now this is in the form A, my real value, plus B, my imaginary value, I. That's your final answer. Because I is more simplified than the square root of negative 1. Okay? Leaving something as a square root of a negative is not fully simplified. Not anymore. Okay? All right. Yesterday, if I gave you in the denominator 1 plus the square root of 5, do you remember what I told you to multiply by? No. The opposite, 1 minus. And do you remember what I called it? The conjugate. Good. So, in this case, we're going to also use the conjugate. Because it's I being multiplied by a number, whereas here it's I being added or subtracted from a value. Okay? Okay, so the conjugate of A plus BI is going to be A minus BI. Okay? So the conjugate of 1 minus 4I is going to be 1 plus 4I. I'm sorry? So if we just tried to multiply by I over I here, we wouldn't get rid of it all because we'd have to distribute it to the 1. So we'd still be stuck with the I in the denominator.
So if it's multiplying, you just do it by I, but if you have like adding and subtracting, you do the whole denominator?
Yeah, just like we did with radicals. Okay, just like we did with radicals yesterday. Okay, let's distribute for our numerator, okay? 3 times 1, 3 times 4I, plus 12I. 2I times 1, 2I. And 2I times 4I, 8I squared. Over 1 times 1, 1. 1 times 4I, plus 4I. Negative 4I times 1. And negative 4I times positive 4I. Okay, do you think it's a coincidence that this is happening? These middle terms? No. We set up A minus B times A plus B. Okay, just like we did yesterday. So that we would use that rule, that difference of squares, to get A squared minus B squared. All right, let's start canceling out where we can. Okay? First, let's work with our numerator. I know 12I and 2I can be combined, right? And I know plus 8I squared turns into what? Negative 8. So 3 minus 8 is? Negative 5. 12I plus 2I plus 14I. Everyone okay with the numerator? Okay, let's look at the denominator. Plus 4i and minus 4i cancel. Minus 16i squared plus 16. So 1 plus 16, 17. Okay, and my last little step. Separate it. So negative 5/17 plus 14/17 I. Yeah, if either of these fractions reduce after you split it, you would definitely do it. Okay? Question? You okay? All right. I want you to try 12. Okay, I want you to try 12. Remember, you're going to have to multiply by the conjugate. All right, so let's talk about this. What did you have to multiply the top and the bottom by? Okay, and what is the conjugate here? 4 plus 6i over 4 plus 6i. All right, for your numerator, you should have gotten 8i plus 12i squared over 16 plus 24i minus 24i. Hold on. Minus 36i squared. Yes? Okay. My numerator, this turns into minus 12. So this is negative 12 plus 8i plus 36. There's an extra back there. So this is going to be over 52. Make sure that you split this. Okay? Negative 12 over 52 plus 8i over 52. Have a great weekend. Yes, but the bell's rung. Then you would simplify this. Negative 3/13 plus 2/13 I.